Alright, welcome back. In the last session, what did we do? We migrated our code from GitHub to Azure DevOps. And why did we do that? Because this is the baseline, this is the first step to create the CI/CD. Is Azure DevOps the only tools to set up the CI/CD? No, there are a bunch of other tools also like GitHub, GitLab, Bitbucket, and whatnot, likes of Jenkins as well. Why did we choose Azure DevOps? Because we're going to create an Azure Kubernetes. So far, what we've been doing is we've been deploying workloads on Minikube, but that's not going to happen on a production or client environment, right? There's going to be an actual Kubernetes cluster, be it OpenShift on premises, be it on Azure Kubernetes, Elastic Kubernetes, or Google Container Engine. Could be any, or DigitalOcean Kubernetes, or it could be anything, right? So what we're doing is we are using the entire Azure ecosystem, running the CI/CD using Azure DevOps, and then creating the Kubernetes cluster on Azure. All right, so this is the first step to have the repo, have the code onto Azure DevOps Git, and then start setting up the CI/CD platform. Before setting it up, we need an actual cluster also. In this session, I'm going to create an Azure Kubernetes cluster, so you can go ahead and use a free trial Azure account. That's what I've been using. So what I'm going to do is I'm going to just go to the landing page, look for Kubernetes service, and yeah, that's about it. Go to the create cluster, click on create a Kubernetes cluster, and it's going to ask you a bunch of questions. Now this is going to be about the subscription. Subscription is the top level hierarchy into Azure, and then you've got resource group. I'm going to create a new resource group, so that's going to be Helm RG. Resource group is just like a namespace, a logical container to keep your resources, and then I'm going to give a name to our Kubernetes cluster, Helm deploy. All right, and then the region. You've got plethora of region: US region, European region, Australia, whatnot. Zone, you've got 1, 2, 3 zones, which means your data is actually replicated across 3 different zones separated by physical latency, right? For now, it's just a test environment, so I'm going to keep it as probably no zone, and I'm taking the server availability as 99.5 to optimize the cost as well, because I don't care. This is completely a dummy environment or a sample, a dev environment. In an actual production environment, you would ideally like to keep it as high as possible, because in case of natural disaster or flooding, your availability zone can help you to build up a resilience cluster. And then you've got the size. I'm going to use a standard size, and then scaling based on your loads. You want your nodes. Kubernetes consists of multiple nodes, right? And these are virtual nodes. So either you can auto scale them basis on load, CPU loads, or traffic, or you could just do a manually set it manually that maximum it is can go to is 2. I'm going to keep it as 2 because I don't want to incur a lot of money. So we're going to keep it 2, and then I'm going to click on the node pools. Now node pool is something called as to segregate your application. Now there could be certain application which needs a quite higher consumption when it comes to memory or CPU, like Elasticsearch. It's a memory hungry application, right? Because it's based on Java. So for those, you can create a different node pools and start deploying your workloads over there. For now, I'm going to keep it as it is, and then access, you could enable the rollback and integrate with Azure Active Directory. Azure is pretty famous for Active Directory, right? So you can integrate directly with it. Network, if you want to use the kubenet or Azure CNI, you could use that also. Then you've got advanced, if you want to use the CSI driver, tags. I'm going to use a tag as created by Sean, and that's about it. And then I'm going to go to review plus create. It's going to review bunch of validation, run some validation, whether the name is correct, whether the region is fine or not, node pools names are correctly passed or not, configuration is there or not. Once it is satisfied, you can start click on create, and within like 10 or 15 minutes it should be able to create a full-blown Kubernetes cluster, wherein in the next session we're going to see how you can start deploying our actual workloads into the cluster as well. That's about it. I'll see you in the while once the cluster is created in the next session. Thank you.